Hello, welcome back to more fun fixing it. I've got 4 ZX Spectrums on, well, there's another one over there. Technically, there are 5 ZX Spectrums on my workbench. That one's my test machine. There's 3 here that are all missing voltages. I'm hoping that I will be able to just fix all 3 of these just by a simple repair, just replacing a transistor. Then we've got this one, which is another potentially simple repair because I've already gone through and triaged all of these, which is why I know that they've got missing voltages. But this one is in absolutely brand new, immaculate condition. This looks like it was just bought and left in the box, but it doesn't work. And it's got a bad ULA, which is quite a shame. But we're not fixing that one today. That's probably not going to be a video. I will just, I don't know, it will probably get a ULA from another much more ratty machine and then be sold like this. So yeah, that's one for another day. But these 3, I'm quite curious to see if I can fix all 3 of these with just one simple part that I'm hoping is wrong. I want to show you first of all how I go about triaging these now. I do them in a slightly different way to before. So they're all opened up. So let's dig inside. This is an issue 2, -2 ULA, original caps, ROM is in a socket. Everything looks okay. Nothing has, it doesn't look like it's had any work done in here at all. Yeah, it's all factory. Now, I used to go through and check resistances for all of the voltage rails, but just for speed's sake, and I know it can't do very much harm, if I set my bench power supply to 800 milliamps and 9 volts, and I plug in my Steam Card Pro, which will show me if any voltages are missing. Oh, this has got a fancy one wire. It looks like a cable tie in there. Look at this composite mod. Oh, look at that. A 1-wire composite mod that somebody has already done. I mean, if it works, it works. I will replace that with a capacitor. But now what I do, knowing that I can't do any damage because the bench power supply is got a current limit if there's a short on here, and I can see instantly if any of the voltages are missing. So I just, let's turn the bench power supply on and ready. So 12 and -5 volts, the top and bottom of this Steam Card Pro. Ready, 3, 2, 1. And you heard the beep then as well. That means that the machine is running, but it's missing some voltages. Now I can take the board and then measure TR4 and TR5 with my multimeter. Right, so in diode mode with the black lead in the middle of TR4, I've got 0.59 that way and nothing that way. That's wrong. And then with the red lead in the middle, yeah, there's a dead short across those bottom 2. And then 0.9. Let's just check TR5 as well. 0.7, 0.7. And everyone's multimeter will be different, by the way. So and that is wrong as well, because there is a chance that... actually, let's check for a short. It could be the TR4 is messing around with the readings on TR5. No, there's no short there. But there is across the coil, and I expect that's because TR5 is shorted. Sorry, TR4 is shorted. The transistor in TR4 is a special one. It's like I think it's a 1 amp transistor. It's, if you put in a normal replacement equivalent transistor, it will just blow. It's quite a high current draw on it. So I've got a ZTX 651 here to go in there. I'm going to have to restock on these, but these are quite expensive. The transistors are usually quite cheap, but these are actually reasonably expensive to buy many of them. I tend to get through quite a few because they tend to blow quite often in Spectrums. There we go. Now I should be able to measure no short across that coil actually. Yep. Perfect. That's exactly what it should do. Okay. Now, hopefully, if nothing else is broken on here, it could be that there's a shorted chip somewhere that's actually caused that to fail in the first place. But hopefully that was the only thing that was wrong with it. Before I go any further, I'm just going to check this old transistor in my component tester here, just to make sure. It says 2 resistance, one 8K and one 3.3 ohm, so just almost a complete dead short. Now, let's put this back in, and here we'll see if the voltages have reappeared. Yep, 12 volt was actually quite reluctant to come up then. It took a few seconds. So this is actually got a composite mod in, so I should be able to see if it's got a display. Oh, yeah, that doesn't go in all the way because they've soldered that wire straight into the middle of the socket. So it might not display properly, but yeah, there we go. It's not a great display. Okay. So that's that could right. So that's come up as M1 possibly being bad, and on the Steam Card Pro is a switch here to ignore the M1 line. So I'm just going to switch that to yes, and if that changes to recognizing the ROM, then this CPU has got a bad M1 line. I've had a rash of these recently. I fixed 2 yesterday, and this is the 3rd or 4th one I've seen in the last couple of days. Yes, this has got a bad M1 line. Right, so that's working. I'm just going to test while that's doing its thing. I'm just going to test the voltages just to make sure that they are all good. 4.5, minus 4.5 is a bit low. 12, 4.97 is fine. That might be why it blew. Right, so I need to do a proper composite mod on this. And once that's done, tune the output with the variable resistors, etc. I picked up some really cheap desoldering braid from AliExpress. It's not as good as the MG Chemicals one I use, but for this sort of stuff, it's perfect. I don't want to waste my really nice MG Chemicals braid on this sort of easy sort of work. I can just chuck this in there and it will do what I want it to. There was quite a lot of solder in there. Will that go back in there now? I think I'm going to have to try and get some braid inside that socket. Still a ton of solder coming off of the outside of it. I wonder if that's actually just flowing from the inside. Yeah, that's much better. That's exactly how it should work. Right, let's get a capacitor in there. Capacitor with its legs bent up like this, with the positive lead on the motherboard and the negative lead going to that RCA jack. Grab that in there and just yank it up. Right, just a little dab of solder just to hold that in the middle of on the outside of that pin so it doesn't interfere with it. Now I should have a better composite mod. Okay, we've still got that horrible yellow screen, so I'm just going to grab my oscilloscope, attach that to the output. You can see that that trace is a little bit thick. And I can just adjust these two variable resistors until that line gets a bit thinner. That's getting worse. Let's go the other way. All right, getting better. That looks good to me. Not a bad ULA, this one. Excellent. Right, so this one's got a new membrane, so I can test that while I'm here. Press my NMI button, and then I should get... Excellent. Okay, so this is fixed. I would, if I was buying this myself, I would recommend that the caps are replaced with new ones, but it is working, so that's how it's going to be sold. It's up to the person that buys it. It will be sold in the full knowledge of the person that buys it that it has not been recapped. But that's as far as we go with this. If it tends not to add, a computer sold without a recap that's working will be around the same value on eBay as one that has been recapped. And you know, to recap a computer, if you add that value into it, it just is wiped out instantly. So that's the harsh realities of it. It's a business for Paul. Well, I suppose it's more of a hobby, but Paul has to do this for the right reasons, and the reasons are not to preserve every ZX Spectrum in the country. That's not his job. Okay, I'll just make a note on this one and then we'll move on to the next one. Right, TR4 replaced and video tuned. That one's done. It's all very well working on something safe and plentiful like my beloved ZX Spectrum or Commodore 64. There are literally millions of these things being dug out of sheds and attics all the time. But what if you want to explore something a bit more obscure? Buying a rare vintage computer like a Computer's Lynx these days is a huge investment. But there is another way, which brings me to the sponsor of today's video, PCBWay. Thanks to the amazing retro community, enthusiasts are actively reverse engineering these incredibly rare machines. So instead of hunting down an expensive fragile original, you can take those open source files, upload them to PCBWay and have a brand new professional quality replica manufactured. Take these Computer's Lynx PCBs I was generously donated. PCBWay makes bringing a forgotten system like this back from the dead completely accessible. And if you're building smaller expansion cards, memory modules or custom adapters to get these obscure systems running on modern displays, they can fabricate standard boards up to 100 by 100 millimeters for just $5 for a batch of 10. They can even 3D print missing keycaps or CNC machine custom cases to finish the build. Don't let rare hardware become a lost piece of history. Check out the link in the description to get your custom boards and parts made. Big thanks to PCBWay for supporting the channel. And to Lester for sending me these. This one is also missing 12 and -5, the same as the last one, so we'll do this one next. And it's another issue 2, and this one is an upgraded 16K. And it's had the DC-DC mod done at the factory. Probably when this was sent into the factory to have its upgrade done, so they would have popped in these chips, and then they would have just added this capacitor and changed this resistor here. They've stood them up off the board in quite a weird way. That resistor there is stood up as well as this capacitor. So again, I'll show you what happens with this one. It's got like a really white ceramic capacitor there. If I turn it on, no minus 12, and no plus 12 and no minus 5. At the back of the board, there is signs of rework. Maybe they retouched a few joints here and there. You can see where they've done the DC-DC mod, but everything else looks, what's that? Dead bug. Yeah, TR4 may have been changed. It's got very long legs. But let's have a look at that first. All right, TR4 with diode mode, black lead in the middle. That's wrong. 1.3 is wrong. 1.9 is wrong. And the other way, 8.4. Then none of that makes any sense. TR5, black lead in the middle. 7.7-ish. 1, that should be open. And across the coil, yes, weird readings going on there. I think it's TR4 again, but we will see. I'm gonna have to take it out to find out. I'm still yet to have a bad coil. That one looks okay. But this one could need a recap as well. There's a chance of that. Let's just check this in here. Ah. That's interesting. That ZTX 650 is testing normal. Oh. Now it's not. Yeah, it thinks it's two separate diodes. All right, let's stick a fresh one in there and see if that brings it back. I'm not sure if it will, actually. I think there might be some other problems here. There might be another reason that the transistor blew in the first place. Or it just went faulty in a weird way, and that's why I was getting the weird readings. Okay, we have now got the voltages, and we've got the beep beep. That means the diagnostic is running. So the first thing I want to do before I do anything else is just quickly composite mod this, and then we can see what's going on screen. I could use my Henry composite mod, but this has got to be composite modded anyway, so let's just get it done. Right, let's see what we've got on screen. Oh, we've got a good image. Another one that survived. Right, that's fine. That's passed. I can put this back together. I am just actually, before I do, I'm just going to connect up while I've got it here and it's all set up. I'm just going to connect the scope up to that video output and give that a tune. Yeah, this looks like it needs a tune as well. Yeah, that's a much nicer, whiter screen. That'll do for this one. Let's put it back together. I don't think the membrane might have survived. Let's try it. No, not a single key. Oh, membrane is completely dead. Right, TR4 replaced and video tuned. Bad membrane. Issue 2, 48K. So the last one is only missing -5. This is a bit more interesting. And I'm curious to see if this is still a TR4 problem. But the 12 volt, I would expect that to have been trashed as well. So look, you watch here, just the -5 is missing, which is bad news for the lower RAM. That means that we could have lost some lower RAM, but it was running. You heard the beep as it fired up, so it could be that it's okay. So let's get TR4, well, let's investigate, see if TR4 is a problem. First, what have we got here? This is an issue 3, so TR4 and TR5 are down here on these ones. Okay, black lead in the middle of TR4. Nothing that way, nothing that way. Red lead in the middle, 0.6, 0.6, that's normal. And 0.6 that way, this is TR5, 0.6 that way. Nothing that way, should be 1 point something that way. That's normal. Interesting. That's normal. That's normal. The coil is okay. What's happened to the -5 volts? Okay, I'm going to head to the schematics and have a look, see where it comes from. I'm pretty sure, do you know, I've got the soldering, or the desoldering station is hot, so I'm actually just going to buzz TR4 out and test it out of the board. Just because it's super easy to do. Yeah, that looks normal. There's nothing wrong with that transistor. That is quite interesting. I don't think I've had one like this before with missing voltages, but it's not TR4. TR4 is like a fuse in these, like an expensive fuse. Curious. Let's have a look at the schematics. So we've got the schematics here for the issue 3 ZX Spectrum, and this is the, well, this is the whole DC-DC conversions part of the circuit, where the 9 volt comes in here, it goes through some capacitors, the 7805 converted down to 5 volts. Some of it is passed through. The 9 volt is also passed through and into other parts of the circuit. They're like there, for instance, but the 5 volt goes in here, goes through TR5 and TR4, and with this mix of capacitors and resistors and diodes, and here we get 2 lots of plus 12 volts coming out, and minus 12 volts, which goes to the edge connector. It's not used anywhere on the board. The -5 volts that we're looking at, and ground is here. With the -5 volts here, we've got the plus 12 over here, but we haven't got the -5, and we have got the other plus 12, otherwise we wouldn't have a display. Pretty sure that this one, or I'm not sure, actually one of these is the video display and one is the plus 12 for the lower RAM. So the -5 volts down here, if we work backwards, we've got a resistor here at R54, a capacitor C47. Which one is that? I need a board layout. Okay, right, so C47, this capacitor here is down here, which is this one here. C47, so that's the main capacitor on the -5 volt rail, so we could be looking at a bad capacitor. Actually, look, let's give that a quick test with my LCR meter. That is going to be, I'm pretty sure that's a 22 microfarad capacitor. Oh, 638 ohms at 32 microfarad. That is high. Yeah, very high ESR resistance. I think we might have stumbled straight into it straight away. I'm just going to whip that out. Again, the desoldering station is nice and hot, so I can just buzz this out. Test it out of the circuit and see what that does. That's actually got quite low resistance across it now. 4.3 ohms and 36 microfarad. That's actually not a bad cap. So that's not where the resistance is coming from. resistance is coming from somewhere else up the chain. That's, yeah, right. R54 is the next thing I was looking at. That's meant to be a 100k resistor, and it is. We've next got a diode at D12. Right, D12 is here between the two capacitors, that one in there. That could be a problem. Let's see if we can test that in circuit. Nothing that way. That looks normal. I've got a feeling there's a chip that has gone high resistance here on its -5 volt rail. But we'll keep going back. There's D16 is looks like a Zener diode, is it? 16, right? There's this diode here. Six. And that looks okay in circuit. Obviously, there's a pinch of salt to be taken there. A 56 ohm resistor at R55. It should be 56 ohm. Yep, that's perfect. And another diode at D11. That looks okay as well. And then the last thing is C46. Is that capacitor there? C46 is another electrolytic. So we'll measure that with the LCR meter. I think this one is a 1 microfarad, maybe. Right, so that's 62 microfarad and 27k of resistance. Now, this could also be getting thrown off by the whole high resistance thing that I'm seeing. It could be the resistance is coming from elsewhere in the circuit. So I'm going to just pop that out and measure it out of circuit. This is a 1 microfarad. Oh, that's miles out of spec. 119 picofarad. That might be where all the resistance is coming from. I wonder if I can measure any resistance across this now. Yes, that 100k from that resistor. That's good. All right, hopefully that's it. I'm just going to grab a 22 and a 1 microfarad capacitor to replace those two. Let's see if that's made any difference. I haven't removed anything else, have I? No. Do we get... Oh, that's... Do we get the voltage -5 now? Yes, -5 is back. So you can get... Capacitors can cause the voltage, the bias voltages to disappear. And if one of the bias voltages disappears on these boards, then the lower RAM can, if it's left on for an amount of time, the lower RAM can just disintegrate. It can literally go nuclear and melt itself from the inside out. So I need to composite mod this quickly. I'll be right back after I've done that. After these words, not after these, well, probably after these words. Okay, composite mod complete. Or it will be once I put this lid back on. Composite mod is now complete. Let's get the diagnostics in there. See what we get on screen. Oh, not a great image actually. Oh, okay. So I think I know what's going on here, but it will be nice to see if it passes. Yep. Okay, so I've got the that's passed nicely, but the screen looked really weird and white and washed out. And now the reason that the computer was missing -5 volts and not functioning properly was because of one of these caps going bad. I think it was the 1 microfarad cap was really bad. I think that the rest of the board needs a recap as well, because I think that especially the 12 volt supply coming to the LM1889 is a bit of a problem. So if I'm going to measure the 12 volts at the RAM, which is 12.26, and that's this cap here is supplying that, and this other one supplies the voltage to the LM1889N. I think that that's out of whack. I think there's something else going on there. So I'm going to recap the whole board. This is an occasion where this is completely warranted and necessary. So that 100 microfarad cap, oh no, that's jumped up. Very high resistance though. This one, yeah, they tend to be quite high resistance. One over here on the video generation circuit, it's meant to be 22, it's 32, that's not terrible. Another one from the video side. That one's fine. I think this one's something to do with the clock. And that one's perfect. I'm taking that one out. This is a 4.7, I believe. That's good. Here's the reset cap. Not so important for running, but that's a 1 microfarad. 20 ohms is a bit high, but not terrible. These are smoothing caps, I think, of the incoming power supply, and that is fine. There's another one here, and that is also fine. Some a little bit out of spec, but nothing terrible. Okay, the board is all recapped, and well, I'll show you that what we get now is that. Now that looks reasonably normal, but when I add a bit of colour to it, I'll actually do that by typing in border 5 so that I get a red border. I think it's border. Oh, sorry, border 2 is a red border, and enter. That's what we get. So it's not quite that there's no colour. It looks like it's completely messed up and unstable. Now the colour is generated by the ULA, and I have probed the ULA on the right pins. I think it's pin 14 and 15 of the ULA. 15 and 16 are the two colour balance signals, U and V. 15 and 16, so 19, 18, 17, 16. So that's a colour signal. And 15 is also a colour signal. And I have, oh, this is a different ULA actually. This is the original ULA. Does exactly the same thing. I will put that one back in. And that goes out to the, that comes out of the ULA here, and it goes through lots of circuitry here. Where we used to have the trimmer caps, we've now got transistors, TR, CR8 and TR9 are, oh, this is the wrong one. Oh, I've printed out the wrong one. But anyway, the point is it ends up at pin 13, coming out of pin 13 of the LM1889N, which is 10, 11, 12, 13. Which is our video signal, which does look very messy, and that kind of fits in with what we're seeing. And I'm not sure, right, so there's a few possibilities here. There are different stages. There's the color balance is handled by these two transistors, TR8 and TR9. They have something to do with the signals coming out of the ULA. They're getting mixed together. Just you. So it could be something here. It could also be something in the LM1889N, because that has something to do with it. But it could also then be something to do with TR1 and TR2, which mixes all of the chrominance and luminance signals together to create the actual video signal, which goes into the RF modulator. So it could be one of these. And I've probed around, and they all look pretty messy. And I'm not sure whether it's something broken further up or further back. And so I think what I'm gonna do is do the easy things first. I'm just gonna remove TR1 and TR2 anyway. I've already done a composite mod on this with a capacitor, and it's always a good idea. It's not necessary, but to brighten the image a little bit, you can change TR1 and TR2 with BC549 transistors, and that will brighten the image. Otherwise, if it's not done, and I don't always do it, because like I say, it's not really necessary, you can just turn up your TV brightness. It does the same thing. Okay, that's 2 transistors taken out. I'm going to leave those there just in case this fixes it, and then I can test them after. I've got 2 brand new ones here, and these have to be placed in the board the opposite way around to the silk screen, so with the curves facing to the flat and the flat to the curve. So I'm replacing these, not expecting this to work. I don't think I've ever seen one of these go bad. But it'll be nice, a nice easy win if this did fix it. And I'll just work my way backwards. Let's see if that made any difference. Right, no difference. It's still washed out and horrible. So I know the ULA is okay. So it's something in between these 2 points, and it could be. If this was an issue too, I'd be messing around with the trimmer caps. So it could be that it's one of these transistors here. I have quickly checked all of these. These capacitors here are all part of this mixed in. There's some resistors as well, but the capacitors I've had one of these go bad in the past. They all seem to be okay. I suppose I should give a quick visual inspection to the other side of the board just in case there's any problems. It's pristine on the other side. I wonder if it's the LM1889N now. I'm wondering what TR8 and TR9 can be replaced with. I'm just going to go and check that. Okay, so these are BC18184s. Yeah, BC184s, and it seems that a BC549C, which is exactly what I put in TR1 and TR2 already, is a perfect replacement for them. So I'm just going to pop those out as well. Got the desoldering station already hot. I might as well just get on with this. It's easy to fix. Easy to swap these and eliminate them as a cause. These ones are a drop-in replacement, so they can go around the right way this time. Again, I don't expect this is going to fix it. My suspicion is that it's the LM1889N. I just have a feeling, and it's based on nothing more than what's more likely to have broken. But it'll be nice, it'll be a pleasant surprise if this turns out to be the problem. Right, so it's not that. Okay, so I am just going to take out the LM1889N. I'm not going to try to diagnose it in circuit. I don't know enough about video generation to make educated guesses on what's going on. So I'm afraid I'm going to have to just pop this out. All right, so that's on pin 3, that capacitor, and everything else is not connected. And that should just allow me to pop this out, put a socket in, and eliminate this as well. I think it will be this one. I'm hoping it is, because there's not much left. After this, it's passives. You have to be really careful removing these, because a lot of the pads on an LM1889N connected to, or the position of an LM1889N on a ZX Spectrum, are not actually connected to anything, and they just float away, which isn't a big problem because they're not connected to anything, so you don't really need them. But it'd be nice to not do any damage. I took that capacitor off the other side, and I've just popped it on the back side of the board just to make things a bit neater. Obviously can't, well, I could connect it to the chip legs on the top side, but that would look very ugly and make removing the chip very difficult. This is a much neater solution. Yeah, this is the one I removed, and this is a new one. I'm doubting myself now. That looks the same, I think. It's hard to tell, actually. No, that's good. It's working. It was a bad LM1889N. Just to prove it, I am going to pop it back in. Yep. Okay, happy days. That's a nice, easy fix then. Let's load a game. I'm not going to be able to play it because I haven't got a proper keyboard, but space and 5. We can at least see it. Yeah, that looks good to me. All right, excellent. So we had two missing voltages due to a bad DC-DC circuit with the TR4 transistor blowing in both of those, and then another one in this one. Bad capacitor was causing one of the voltages to be missing. So looks like if two of the voltages are missing, -5 and +12 volts, then it's likely TR4. If one of the voltages is missing, something else. It's always nice to learn new things. But that's 3 spectrums finished. Well, not finished, but fixed and in the repair pile, or in the outgoing repair pile. Oh, that was me jumping. Yeah. Oh, I turned off the sound. That's a good thing. Right, so no bad RAM, no broken PLAs. Just a bad LM1889N making the video signal rubbish. I'll put that in my bad chips bin. I haven't got many of those. I have a few of those have broken in the past, but not many of them. Anyway, I hope you enjoyed that, and I've got more to come. Lots more to come. I'll see you in the next one. Bye. Like and subscribe. YouTube nonsense.